to basic electricity. So we are going to be discussing the basic concept on electricity, starting with the electrical charges, the internal resistance as a result of the attraction between the electrons and the protons in each atoms, and also the external force that we need to apply to the electrons to release to the atom to release the electrons. And also we are going to be discussing that the electrical current concept. The electrical current is the result of the electron in motion. Okay, and so first of all, we need to understand that we have atoms, and the atom on the peripheral area has negative electrical charge, and at the center we have positive electrical charge. So there is an attraction between the electrons and the protons. So in order to release the electron, we need an external force. So when the electrons are released, we have electron in motion, and the external force is what we know as voltage, and the electron in motion is what we know as electrical current. And the attraction between the electrons and protons is what we know as resistance. So the external force is normally produced by companies like Southern California Edison, that has the permit and the license and the technology to produce the voltage and distribute the voltage into the cities. And we get this from the outlet or from a specific and a special electrical panel. Okay, and the voltage, when it's applied to any electrical conductor like copper, silver, aluminum, will release electrons. The cheapest one and the easiest one to release electron is the copper, and the internal resistance is the result of, I told you, the attraction between protons and electrons. So we have voltage is the external force used to release electrons. And keep in mind, the electrons has negative electrical charge. And that is the first concept, voltage. And the electron in motion is what we know as electrical current. Okay, is the result to release electrons by the voltage, and this is measured in amperes. And then we have the internal resistance. The resistance on any material is the result. The resistance is the result of the attraction between electrons and protons. The unit used to measure the resistance is ohms. Ohms. Okay. So these three parameters are related by what is known as Ohm's law. Okay. The Ohm's law establishes that the voltage is equal to the multiplication of the internal resistance times the amperes. So the Ohm's law establishes that the voltage is equal, this is the voltage, is equal to the resistance times the intensity of the electrical current, or amperes, ohms times amperes. So if we know the two of them, we are able to calculate the other one. Okay, so we know the amperage and the resistance, we can calculate the voltage. If we know the voltage and the amperage, we could know the internal resistance of the material. If we know the voltage and the resistance, we can calculate the amperage. Okay, so now we are going to represent an electrical circuit using a block diagram and the main component of any electrical circuit. So the main component of any electrical circuit include the source of voltage, okay? But for my explanation, I will use a 120 volts AC that we can get it in any outlet on any residential and commercial facility. Then we have the protection device. Then we have the load, and then we have the return to the source. Okay, so when we apply an external force of voltage, we are going to have electrons in motion, and the electron in motion will go to the load and produce the electrical job. The electron in motion are in charge to do the electrical job. So either to produce a motion on electrical motor, okay, spinning on the electrical motor, or produce a light on the any lamp, or any other kind of electrical job. And this is the hot line. But the electrons need to go back to the source. To go back to their source, we use what is known as a neutral line. Okay, and the neutral line. In case the neutral is broken, so the electron won't have the electrons in motion will not have the opportunity to go back to the source. So we need a second option for the electron, which is the ground. So on a single phase electrical circuit, the whole line is black color, it's a cold color. The neutral is white color, and the ground is green. Okay, so the protection that we have is a protection against overcurrent. Okay, overcurrent when we apply a load that is demanding more current that could be supplied by and support by the protection, or against short circuit. A short circuit happens when the hot line by accident is touching the white or the neutral or the ground. Then we have a short circuit, because according to the Ohm's law, a short circuit will be equal to multiply ohms resistance times amperes. So if the resistance is 0, we are going to have a voltage divided by 0, and we are going to have an infinite electrical current. We are going to have an arc fault. And so the protection has to offer me a protection against overcurrent when I apply a load that is demanding more than electrical current that the protection can support and protect, or a short circuit that occur or happen when the hot line by accident is touching the white or the ground, the white color, which is the neutral, or the ground, which is the green color, the ground, the earth. Okay, so this is the basic component on any electrical circuit. Talking about the load could be any lamp, any luminaire, and it could be an electrical motor. And right here, what we have is a device that needs a certain amount of electrons or amperes. Okay, so a fluorescent lamp could be working 120 volts, 60 watts, for example. So it will be demanding maybe 0.2 amperes. Okay. Other aspect that we need to take in consideration when we talk about the basic component in any electrical circuit is how do we calculate the electrical job done by the electrons. The electrical job is measured in watts, and the watts is calculated multiplying the voltage times the amperes. So any electrical device, and this is by it's a regulation, okay, and a standard. Any electrical device will be including the watts, the voltage, and the ampere, the voltage and the watts. So you can determine the amount of electrical current that you need. For example, a lamp working 120 volts, 60 watts will be demanding around a half ampere. If we divide 60 by 60, which is the watt, divided by 120 volts. So we are going to have around half amperes. Okay, so that is the amperage. So if we install a protection to protect half ampere, and we install 20 lamps, we are going to be demanding more of the amperage that the protection could protect, and then the device will trip, like in the case of a circuit breaker. Okay, also right here, we need to take in consideration the size, the diameter of the line, the hot line, and the wire, the neutral. So the diameter will depend on the amount of electrical current. Is what is known as American wire gauge. Let me write this. So the American wire gauge. So there is a line that divides between gauge number 6 or smaller, or gauge number 6 bigger. So if we have 7, 8, 10, 12, so these are able to deal with less amperage than if we have here 4, 3, 2, 1, 1, 0, 2 zeros, and so on. These are able to smaller the size, bigger the diameter, more amperage the electrical conductor is able to deal with. Okay. So where do we find the proper size depending on the electrical circuit? We need to use the NNC on the table 310 15B 18, 310 15B 18, and the table 310 15B 20. Okay, let me write this down. 310 15B, 310.15 parenthesis B, parenthesis 18. Okay. and 31015B20. (315B20), 31015B20. So we use this table to determine the size of the electrical conductor. For example, if I need to feed up 20 fluorescent, or let's say 10 fluorescent lamp, I will need an electrical conductor in my circuit that is able to transport, let's say, 10 ampere. So if I go to this table and I check, let's see, on 315B17, which is the other table, 31015B17, I have for a single electrical conductor, 10 ampere at 75 degrees Celsius will be able to transport 50 amperes. Number 14, 30 amperes. I am able to use 14 or 16 at 75 degrees Celsius. Okay. If nothing is said, I use this table for 75 degrees Celsius copper. Okay. If nothing is said by the manufacturer of the electrical equipment or luminaires. In my example, I am telling you that I need an electrical conductor that is able to transport 10 amperes. So number 14 will be AWG, will be enough. And this table is for a single conductor. Okay, so it's an example. So later on in class and in the lab, we are going to talk about these tables more in detail. So keep in mind, I am talking about the electrical conductors, I am talking about the components that made up a basic electrical circuit. So I have the load here, I have the protection, depending on the amperage that my load needs. I have the source here, in my example, 120 volts AC, and I have here the hot line, which is black color, and the neutral, which is white, and the ground conductor. Okay, so I am talking about this table is to determine the size, the American wire gauge for this electrical conductor and this one. Why? Because the same electrical current that is leaving the source is the same electrical current going back. Okay, so we need to use the same size. And the load could be a lamp or a electrical motor, or it could be several lamps, several fluorescent lamps, several incandescent lamps. And I add all the amperage and then determine the kind of protection and the American wire gauge. Okay, so that is everything for today, talking about the basic electricity, an introduction about the basic electricity. So we have been discussing the concept of the external force that we need to use to release electron, known as voltage, and this force is in need to release electron. The electron in motion are known as amperage, and the electron in motion are in charge to do the electrical job, to produce light on a luminaire or to produce the spin of the shaft on an electrical motor, for example. And the size of this conductor will depend on the amperage that my load is demanding, and the protection has to be calculated based on the amperage in need by my load, and also the American wire gauge. And the white color, the neutral, has to be the same gauge than the hot line, because the same amperage leaving the source are the same amperage coming back. Okay, and the ground as well. The ground, I told you, is an alternative return to the source for the electron when the white is broken down at a certain point in my electrical circuit. Okay, and also I was telling you that these three parameters, voltage, amperage, and resistance, are related by the Ohm's law. And the electrical job produced by the electrons is calculated using watts equation. Watt is equal to voltage times amperage. And that's it for today. Thank you.